Today we are going to talk about configuration management. Now let us look at what are the minimum services that a project manager must provide to all the people working on this project. Let us take a simple example. Suppose all of you are sitting in a class and you are given a 10-minute break. So you just walk off from the classroom, leaving your things behind, and when you come back after 10 minutes, it is you expect that everything that you left behind will be where it was left behind. Then we ask the next particular question, whose responsibility is it to make sure that the things that you left behind are where they are left behind? And the answer obviously is the college management's responsibility to make sure that this particular assurance is provided to the participants. Now, what we are talking about the same thing. Suppose you have many people working on a project and they have different artifacts that they are working on, and simple example like somebody having a file name created by one name and another person creates another file by the same name, and then you have a problem. Or somebody by mistake deletes a directory or moves a directory which has a profound impact on, say, a build sequence of the product. So from that point of view, what we need to make sure is, in general, there is a very strong change control system that is put in place for every project, and configuration management system basically is one part of that particular whole change management system. So let me ask a question, that the project manager is supposed to provide the minimum service to all the software developers, like project control, quality assurance, verification, validation, and configuration management. So the changes are made in a controlled fashion, and the integrity, availability, consistency, accuracy, and all these particular things are guaranteed for everyone. In short, work of one person should not interfere with the work of other people. Then we ask question, why this particular aspect is more important for software, and the answer is very simple. Changes to software are unavoidable. The changes take place while the software is in the making process, and the changes take place even after the software is delivered. So the change is a constant kind of a factor in the product life cycle of a software product. Now these changes may be initiated by a variety of people. For instance, the customer may initiate requirement changes, a developer may initiate the bug detected changes, and the product support people may initiate platform or environment related changes. And in all these particular cases, you must have a good particular change control system. So before we talk of configuration management, let us look at a typical schematic change control system. So if you look at the slide now, what you see here is we need to have some kind of a baseline plan for a particular project. Then we need to keep on reviewing the status, then determine if the changes are there or not, and if the changes are there, then we may need to make sure that we update the project plan, we take corrective action, and we share the lessons. That is basically our continuous learning kind of a exposure. Remember, whenever you find fault, take corrective action, change the process. And obviously this may have a consequential effect on several other aspects of a product, and from that point of view the plan may have to be also changed. So this is general schematic change control system that continues to exist in any particular product. So a good change control system is essential when planning for changes. Actually planning in the sense that you don't like changes, but if they do happen, you want to bring them about in a controlled way. So the change control system is a collection of formal documented procedures that define as to how the changes will be assessed and made. So the entire paperwork, tracking system, processes, and different actions at different particular appropriate levels, All this is a part of your change control system. Now, the change control system will normally include authority which authorizes changes, somebody which can also look after the configuration management. That is, in a loose sense, it's like a storekeeper's kind of it's more in a bigger way, but storekeeper's job. Now remember, in a factory, for instance, suppose you are manufacturing a Indica car, and you need to change the housing of a particular tail light. That decision whether to or not to make the tail light change is taken by an engineer. But once that change is accepted, accepting those particular parts, taking care of the old parts, and the issuing of the old and new parts, all this is looked after by the storekeeper. Okay, so the storekeeper doesn't play a role in authorizing whether or not to change the part, but plays a role in whether or not the correct part is being received and issued. Okay, so similarly, we also need to intimate, in case we make a change, the corresponding change will have to be intimated to all concerned. Okay, so this total aspect is basically referred to as a change control system. The main objective of change control system is what? First, influencing the factors that create changes to ensure that the changes are minimal and beneficial. Okay, so this involves like making a trade-off between the scope and cost and schedule and quality and so on and so forth. Second, determine that the changes that we say need to happen actually do happen. That is, to determine that the status of those particular items has changed. Third, we need to make sure that whenever the changes do occur, those changes are communicated to all concerned. As a matter of fact, the all concerned need to be somewhat be affected by taking the decision, but even after making the change, they need to be informed that the change has been made. Okay, and of course, managing the changes, in a general particular kind of a sense. So these are basically the broad objective of a change control system. Now let's go one step further, and you say, what is configuration management? So if you look at the slide, say configuration management is directed at ensuring that the project's product is correct and complete at all times. Okay. Next particular thing, the goals of CM is to maximize the productivity by minimizing mistakes. Now here we are talking of mistakes related to configuration problems, in the sense that somebody was to make a change to a software component and the wrong component or the wrong version got changed, or the change component went to a wrong library, then it's a configuration management problem. It's not a sort of a making the change problem in that particular sense. So one of the categories that we have in fault analysis is whether the particular fault can be attributed to lack or poor configuration control. Okay, so the goal is to minimize the productivity by minimizing the mistakes and increasing the thing. The third is effectiveness of CM is judged by the number of defects reported due to incorrect or inappropriate configuration control. I already mentioned this particular thing to you. And last but not the least, we say configuration management is an umbrella activity which operates throughout the project and the product life cycle. Okay, as a matter of fact, the organization may have several norms and standards for how to undertake configuration management, not for only the single project that we are talking about, but for all projects in the organization. So remember, CM operates during the development and during the operations. So now next question that we ask is, what are the main functions that are performed by CM? So first let's enumerate them. Okay, and once we have enumerated them, then let's look at all these particular functions one by one. So the first and the foremost, if you look at the slide, is configuration identification. This looks like a simple issue, but is a very difficult particular issue. On a lighter side, it's like giving a name to a child, born in your own household, versus giving a ID to somebody on the internet, and that there is a difference in the way you go about doing these particular things. you also need to define, that this particular configuration item belongs here, where, and so on and so forth. The next particular function that we have is configuration control. Once we have put an item under configuration, we need to make sure that its integrity and traceability is monitored, controlled, like receiving, approving, monitoring, changing report, defect reports, all these particular things, and of course releasing the corrected product at the appropriate time, all falls under configuration control. The third particular thing is status accounting. Now, this particular configuration management reporting is a very powerful tool for the management to know whether the product making process is working as planned. Okay. So, the status of the product, and reporting of the product status is taken care of by this particular process. Next particular one is configuration audit. We already mentioned what is audit. Audit is an independent assessment to ensure that the things are happening the way they are supposed to happen. The processes are being followed, and the processes are right processes are being used for the right purpose, and so on and so forth. And last but not the least, like every other activity, we need to organize for the configuration management activity. So, when we look at these particular 5 functions, now let us look at these particular functions one by one. So, first of all, we say what are typical configuration items. Okay. So, if you look at the slide, it says application software, with documents, the typical configuration items are requirement specifications. This is a very important item. Okay. Outline of design, detailed design, source codes, executable codes, for instance, corresponding test data file, the input test file, the output test files, the program specifications, the user manuals, instructions for compilations, executable objects, you name it, all these happen to be configuration items, they need to be identified. Remember why the trouble happens. Suppose we have a source code and we have a object code. Okay, we can make modification to the source code without affecting the object. Now, somewhere down the line we have a problem. How do you know that which particular object corresponds to which particular source code? And in case we have a integrity problem between the source code and its corresponding object code, you are in deep trouble. Okay. So, first thing we are worried about is application identification. Okay. Then we have to take a caution. First thing you must realize, all project inputs are mandatory CIs. They must belong to the configuration control category. So, whenever we have a requirements document, whatever received from customers and all that, then acceptance criteria, or what you call any particular data that the customer may give you in terms of test data, okay, items received from the customer like standards, tools, templates, okay, all these are part of your configuration items. Of course, what you must realize that there may be hardware items also which are under configuration control, and there may be physical documents also under configuration control. A customer's contract, for instance, may be a hard copy signed by the customer, and in which particular case this hard copy itself becomes a configuration item. Okay. Now, we need to ask a question, what is not a configuration item? So, any in between communication letters, status reports, time sheets, project specific forms or guidelines which are used, they do not really form the configuration items, they do not need to be preserved in the sense of identifiability that we are talking about. Now, once we got the items, identified, that is only the beginning of the story. So, if you look at the slide again, now we talk of versions of CI. Okay. Every time you check an item in to a configuration stores, okay, this particular configuration stores will give it a version number. So, suppose we start from here and then the object will be numbered object 1.0. Now, every time this item is issued out and received back, it must receive another version number, say 1.1. Now, many times you find that the manufacturers are working on several configuration versions. Okay. Take a typical example. Suppose you are supporting an RDMS product like Oracle or any other particular product that you may think. So, what you will have? You will be supporting the current version, you will be supporting past set 2 versions of this particular product, and you may be working on next 2 versions of the product. Now, again you are going to ask me a question, why 2 versions, why not 1 version? And the answer is very simple, completing a version and putting it into market is a very different thing, So, one version will have been completed and it will have gone for production, launch, distribution and that sort of a thing. It is going to take a finite time and a finite amount of energy to put this particular version into market. And while that particular process is going on, you are not going to sit on your backside and do nothing. So, what you are going to do is we are going to continue to work on improving the product, So, from that point of view, you will always be working on 2 future versions, one a finished version which is up for marketing and the other one which is particular thing. Now, another very important aspect that you must realize is that the versions that you are having, okay, usually there is only one appropriate correct version that is in the market, though you support the earlier ones. But there is another different aspect called a variant. What is a variant? See, remember, multiple versions do not coexist, only one version will exist at a time. Whereas, you may have many variants of the same product in the market at the same time. What do we mean by a variant? Take a simple particular example. Suppose you had a banking product and it was sold to one particular bank, and after that particular product you need to sell it to another particular bank, and that bank may want some minor modifications, and though you are a firm believer of using the products on as is kind of a condition, you may sometimes want to do minor modifications to a product. So, this minorly modified product would really be variant. So, several variants of a product may coexist. I will give you a very interesting example. Sometime back Indian Airlines had put into use a reservation system, and they wanted to do away with the concept of the wait list number. So, they gave each particular passenger some PIN, PAN, TAN kind of a number, and like at any point of time you had to only say that whether particular number that you had in your possession, whether that particular number had come up. But people found that this particular thing was not acceptable. They were years together, they were used to the concept that you go to Indian Airlines and they tell you that your wait list number is 36, and if you check after 2 hours, you expect the wait list number to go down but not up and kind of a thing. And when the call is made for the people who are waitlisted, it is easier for them to conceive, that wait list number 1, please come forward and check in, rather than saying that some P28396252, come in and check in. Okay. So, in this particular case, they would have to make a different variant of this particular product if the company was supplying that sort of a software. Different problems may exist in different countries and that sort of thing. So, we have versions and we have variants. Okay. Now, we have another particular concept that we need to understand, and that is the concept of a baseline. What is a baseline? Baseline refers to a set of configuration items which together depict a product, okay, at a specific point of time. To give you a very simple kind of example, let us take an example of say Microsoft Office kind of a product. The numbers that I am mentioning may not be correct, but I am just illustrating on a particular thing. So, suppose you had a Office 97 and then you had Office 2000 and you had Office, whatever the other versions. Okay. So, when you had Office 97 in the market, Office 97 consisted of a Excel and a Word and a PowerPoint and so many other particular pieces, and each of these products themselves may not have been at the same version. So, you might have one product at version 5 and another one at version 9 and the third one at version 6, and we say these together constituted one particular product. And when you went to the next product, some products might have undergone 3 version changes, and another product may not have gone any version change at all, So the new baseline would consist of the current versions of all the products that are involved. Okay. So baseline is a collection of it's a set of configuration items which together depict a product. Okay. It may be associated with each baseline. In addition to the items may also be a build sequence. Build sequence is the sequence in which you put the product together. Typically when you are installing a software, all this function is performed by a utility called quote unquote install, and when you say install, this utility goes and picks up the right components from the right place and puts them in your machine at the right place. Okay, and in case it finds that a particular number of component number or something is missing, it gives you error message saying that such and such file is not available or something like that. Okay. So the build sequence of putting the items together to make it a working product. Remember what you are doing in a build, you are making a collection of items and putting them together to make and look like a single particular item. So the baselines are tested, and certified version of a particular product, and only approved items are accepted into the baseline. Okay, and making a change to the baseline has to go through a very controlled and documented kind of a procedure. Now let us look at the slide now. So conceptually let us look at what is the baseline. Okay, so what you see here is you have identified a series of items. Remember, all the items in a particular product may not get identified at time 1. Typical example would be that at the time when you are doing the requirements, you obviously don't even know which source codes are going to be existing. You are not yet made a design, higher level design, so you don't even know which components are going to exist. Okay, but your policy says that each source code will be a CI, and a corresponding object code will be a CI, and so on and so forth. So what happens is the items like requirement specifications and all that may become available early in the game, and things like design, coding, test data and test reports, all these things may become available as you progress. Now suppose you have to make a beginning, and we say when we made a beginning, suppose we had item 1, 2, 3 with us, so we make a baseline and you say, to begin with, it's like a starting baseline, and you say version 1.1 of item number 1 and version 2.2 actually is the version particular part for item 2, it's just been for convenience, it has been depicted as 2.1 and version 3.1. It's not meant to be version 3.1. Okay. So you have items and corresponding to it you have the versions. So you have 1.1, 1.2, 1.3 as the changing versions of item 1, and similarly you have changing versions of the same. Now after a predetermined time when you wanted to take another particular baseline, item 4 had also come into existence. Item number 1 had undergone 2 changes, item number 2 and 3 had undergone 1 change of version, and of course the item number 4 came into existence for the first time. So your next particular baseline is going to be V1.3 and V2.2 and V3.2 and 4.1. Similarly, when you go a little now as you go deeper into the project, you will find that the changes to the initially defined items may not be as serious or may not be as frequent, whereas the subsequent items may undergo changes. So the third particular baseline has this particular collection of items, and then you have the fourth and the fifth baseline and all that. Okay. So the schematic depiction of the baselines is shown in this particular fashion. We ask a very simple particular question: when do we do the baseline? It's like asking yourself, you look at your old album, photograph album, and you say, do you have many of your photographs in your album? So you say yes, over your lifetime you have several photographs, starting from the first one in your birthday suit, to all along you have lots of photographs, at different particulars. Now you ask a simple question: when do you take these photographs, and which are like landmark photographs, and you will say, yeah, maybe one was somewhere down the line when you were born, and then maybe another one when it may be very important, when you were went to school the first time, and when you got through the college, and then another one when you got married and maybe you had children and so on and so forth, kind of a thing. By the same particular token, typical application development baselines are, First is the initial baseline of the project. That is, when you start the project, you identify all the items that are handed over to you as point 0, is the first particular baseline. Then we ask next, when is the next appropriate time? So, it is like asking, in case you are going to take your picture once in 5 years, would you take it on any day of the year, or maybe you would prefer to take it on your birthday, or some specific day which you tend to remember easily or something like that. Similarly, another good point to take a baseline is when the SRS is completed and accepted. So, we have a SRS baseline. We may take another baseline, for completion of design. Now, we do not have a baseline for completion of coding for a simple reason that all coding never gets completed at the same time. So, the next baseline that we have is when the integration of the product is done. That is the first time when the entire product, all components put together, the entire product looks like and functions like a single system. And then this particular system is subjected to testing and all that, system testing, acceptance testing. So, whenever the product is accepted and the product is handed over to the customer, and like saying that you wind up the particular product, then you make it a acceptance baseline. Similarly, in case you had a conversion project, then the baselines would be like initial source baseline will be there, then a filtered source line. Filtered source line is a passing all the source code that you received through a program to alter it to the target environment, okay, which probably will do maybe 85, 90, 95% of your work, and the remaining few percent of the work you will have to do it manually. So, once that work is done, you will have a converted baseline, and last but not the least, when you release the product, you will have a release baseline. Okay. So, the configuration baselines are very important from a software project's point of view. Now, next particular thing that we want to understand is configuration control. Now, what do we understand in configuration control? It involves evaluation, coordination, approval or disapproval, and implementation of changes to the configuration items. How is it organized? So, look at it, the diagram. Simple thing is, on one side you have the work area, other side you have the customer and the third parties, and we see that no job will ever leave the work area and directly find its way to the customer. It must always go through a CM configuration control. Okay? What that particular thing means is, any work from the work area will go to CM. If required, it will be reissued to the work area, and this process may continue as appropriate, and in appropriate time, you will have this particular product being delivered out to the customer or third parties, whatever appropriate. Now, in the control area, you have a CI library and the metadata. What is CI library? Is the physical place where the storing of configuration items takes place, and the metadata is the data about the data. Now, let us look at the CI library. For instance, if you are doing a conversion project, your software components may reside on 2 machines. Okay. So, your CI library now will be one logical library, but 2 physical libraries, one on one machine, another on another machine. The same thing may happen in case you are working on a multi-site kind of a contract, and you may have one particular CI library at one location and another one at another particular location. Then you have problems like some of them are software components, but there are a lot of non-software components which also need to be put under configuration control, like we gave the physical documents like contracts and so on and so forth. So, those particular documents will also be a part of the CI library, but probably it may sit in a cupboard. Okay. We have lots of other things. Suppose the hardware for a particular project has been supplied by the customer, and keeping track of that is a particular problem. Then the physical hardware may also become a part of the, technically part of the library. Okay. So, we have configuration control mechanism for that. So, the configuration control mechanism starts by operating with the initiation from a defect report. So, you have either a defect report from the development team, or you have a change request which comes from the customer. Okay. So, each of these particular items where these particular reports will consist of several items like configuration item identity, the date the defect was found, the description of the defect, the effect of the defect, the action taken to contain or recover from the defect, what is the suggested solution, what is the urgency of the problem, all kinds of things. Similarly, a change request may also say which is the item or needs to be changed or added, date of request, the description, then the reasons for the request and the likely effect on the change, So, all these particular things will be initiating that particular. Once we got that, how does the physical change control process operate? So, let us look at the slide again. Okay. So, we begin with a change request. Okay. Once we got the change request, what we need to do is first to identify and record the request in some kind of a log, request log, So, request log will have a list of all the change requests that were lodged with the particular product. Once we got this logged, the next particular thing is somebody has to sit and do impact analysis, okay, and approve whether or not this particular change is worth it. So, performing impact analysis, okay, and approval or otherwise, is the next job. So, this particular job is called change impact forms are there, and you would like to make sure that this particular change has been suggested, is it worth doing, what its the implications is. If you approve the change, the next thing that you do is the item to be modified is checked out from the CI store, the configuration store, okay. And once you do the change, in the metadata you will mark that this particular item has been issued for modification. Once you mark the metadata, another copy of the same particular item cannot be accidentally issued to another particular person. So, you are not likely to have a problem that two people working differently on the same component to make modification. Now, once you got this particular modification done, then the person who did the modification needs to make sure that the change was made correctly the way it was supposed to be made. So, adequate amount of reviews and testing will have to be performed, and the corresponding records generated. Once that change has been made properly, next thing is to accept the change into the store and make changes to the metadata. Now, this particular thing may look trivial, but it is not. It is like, how many times you had a packing list which was different from the contents of the box, and the answer is very simple. By the same token, the developer may tell you that he is submitting version 1.8 of a particular component, and what accompanies in the accompanying file is a version 1.7, or such particular problems can happen. So, once you have the change check in, then the corresponding version number is particular thing changed also, okay. So, once you have done that, we close the change request and we write so in the log saying that the change request has been implemented, okay. And last but not the least, once that has been done, we intimate all concerned that the change XYZ has actually been made. An important entity in the change control procedures and configuration management procedures, is a concept of change control board, CCB, which is often called as CCB. Change control board is a formal group which is responsible for approving and of course otherwise rejecting the change request. Please understand, all the change requests are not of same particular priority, and the analogy like the car not starting, is a category A problem which needs immediate fixing, and the car not having a headlight or a horn or getting stuck in a particular gear, that means it works but not to full performance level, would be the second particular level, and the third would be having a scratch on the paint. And you will say yes, whenever the car goes for repair, such kind of changes can be taken care of at that point of time, okay. So, the CCB's decision to make, accept or reject a change is not merely dependent on your giving a request and the genuineness of the request, because the CCB has to take into account several considerations. So, the primary function of the CCB is provide guidelines for, first of all, for preparing a change request, how to make it, then providing a guideline for evaluating the change request, and last but not the least, managing the implementation of approved changes, okay. So, CCB may have procedures for retrospective handling changes also. Take a simple example, if there is an emergency kind of a change, that somebody may be authorized to make that particular change on the spot and take approval from the CCB retrospectively. Okay. So, this kind of thing can happen in a live production environment. If something goes down, and needs automatic immediate fixing, then such a extreme action may have to be taken. There may also be a concept of automatic approval for predefined categories of changes. Take a simple example. Suppose you have a screen, and this particular screen, the template or the format has some spelling mistake. Say name has been spelled as, instead of NAME, you have spelled it NMAE, and obviously such thing needs a change. But making this change is not going to have any impact on, say, cost or schedule, okay, or any other customer relationship related kind of problems or impact on the quality. Then we say that this kind of a request, the approval of such request can be easily done at a lower level than the CCB. Okay. So, these changes need to be documented, but at the same time they need not go all the way up to CCB, and the designated authority may be allowed or authorized to make some particular change. That brings us to another question, is CCB a board or is it a single entity? And the answer is again depends. In case it is a small project, then CCB is a single person entity. If it is a very large project, CCB may be a group of people, or it may have a hierarchy under it. Okay. If it is a multi-site project, you may have two power centers, like we say in politics, two power centers, and CCB may be split at two locations. Okay. So, please remember, CCB is the authority which decides whether to or not to make a change, when to make a change, and at what appropriate point of time these particular changes need to be released. So, once we have done these particular changes, the next particular thing is change control communication. How do we make sure that all concerned people have been intimated that the change has happened? Okay. The responsibility of making sure that the change is communicated to everybody, basically rests with the project manager. Project manager is responsible for integrating all changes, and making sure that all concerned know about it. Okay. It is important to make sure that all concerned persons are in sync about the latest project's information. No two people should think that they are working with respect to two different components or two different versions of the same components, and so on and so forth. There are many mechanisms which are used for communicating the changes to all concerned. You may have emails, www kind of situations, or you may have special group mails being sent to people depending on the kind of change that has happened. Okay. Or certain special project management software may also facilitate tracking and communicating the changes to the software components. Now, once we got done with the change control, the next particular aspect that we are talking about is configuration status accounting. Configuration status accounting. The configuration status accounting, if you look at the slide, involves recording and reporting the information needed for effective management of configuration. For instance, we might want to know the list of approved configuration identifications at any one point of time. What is the current identifications? What are the current CIs? You might want to know which CI is in which version. How frequently are the versions changing for a particular CI? Too many or frequent changes to CI indicates, that there is something wrong. Either somebody is not doing the good job in doing the initial specification, or somebody is not doing a good job of review, and that the half-baked kind of products are going to field, and once such a product goes to field, it keeps coming back, like a bad penny. It's like the old notes and coins being circulated faster than the new ones. By the same particular token, you will have this thing. Okay. So, you may also want to know how many items, how many requests have been received, of what severity they are, and like severity is only one particular thing, how many have been checked out, how many are in process work, and how many have been completed and returned. Now, once you have developed this configuration kind of a status accounting system, then if you look at the slide again, the next particular thing is that it will help you in answering questions. The management's responsibility to answer this. So, you might want to see, like, again, remember that old particular saying which I keep repeating, that planning is everything, plan is nothing, by the same particular token. You need to ask questions based on the past changes, what kind of changes do you anticipate in the future, okay. So, if you were to ask a question like what are the various versions of the CIs that we are having, how many CIs were open or closed, what CIs are being modified and by whom, and how many CIs were completed, so called, then this kind of questions can be answered from the database that you are going to be using for status accounting, okay. So, configuration status reports should be generated on a regular basis and also provide a ad hoc facility for inquiries. So, this particular thing is what we do. Once we got the configuration status accounting, next particular thing we worry about is configuration audit. What is configuration audit? We have already seen what is audit, okay. So, why do we have audit? To prevent delivery of a wrong product to the customer, to trap incomplete implementation with reference to the original specifications and agreed changes, make sure that the agreed changes are made and stay made, to confirm that the CIs have been appropriately baseline, again baselining is not, like when the product is rechecked doesn't mean it automatically gets baseline. Take a simple example, suppose you were to make a change to a component about payroll system in month of February, you might under certain circumstances want to hold back to this particular item and say I will issue this item in the next baseline only, which will be put into implementation from 1st of April, the change of the financial accounting year, okay. So, such decisions may be there when the baseline is ready. Another very important thing that you need to remember, is that when you have this data, if required, you should be able to backtrack from the proposed change, or made change, back to the original version as required, okay. So, we need to have audits to confirm that the CIs have been properly baselined, to confirm that the documentations, maintains the traceability between the old and the new. Technically speaking, the CI library must be in possession of all the old versions of all the components. This is a very tall order, but for a variety of reasons, if you could retain as many of them as possible is going to be very essential. So, configuration audit ensures that first checking whether all components are complete and correct and no pending issues are there in terms of identification and logging in and so on and so forth, and verify that the integrity of the baseline is maintained, that what you say in your configuration status or accounting system as to where you are with respect to the baselines and the component versions, in reality that is what you are putting in practice, okay. So, the practices and procedures that we have laid down, are they being rigorously followed or not, is one of the important aspects that you need to look at in configuration audit. So, if you look at the slide now, we say configuration audit is an independent, we have repeated this several times, is an independent quality control, it's not a quality control activity, but quality control like activity that helps in ensuring that the quality is maintained and the changes are made the way they are supposed to be made. It is conducted, to enable demonstration of accuracy, integrity, completeness, and disallowed any invalid claims about the particular product. So, these aspects are very important from our particular point of view, okay. Now, we have talked about the 4 functions. The last particular thing we now talk is what is the configuration management plan. We talk of configuration management plan. Typically, in a software development organization, you could have a single project plan, or you could have a project plan supported by knowledge areas, as we have mentioned 8 knowledge areas, and if the project is large, each knowledge area may itself evolve into a separate plan by itself. but many times, you know, all the knowledge areas may not be equally well represented, but the two knowledge areas which are very strongly represented in any project plan normally are quality assurance and configuration management. Okay. So, quality assurance and configuration management plans in their own right will either be separate plans or annexure of a main project project plan, or may be associated as some sections of the project plan. Now, the project plans basically, you know, have a specific objective. You know, it helps the managing of the software development activity. It protects the configuration items from intruders and against accidental wipeout. Of course, protecting against intruder is more difficult, and you know, protecting against accidental wipeout can be done a little more thoroughly. And last but not the least, you know, you'll have to facilitate reporting on the, you know, state or stages of the project, you know. So, you know, like project manager on an ongoing basis in the project reviews will get a good idea as to how the configuration management progress is being the same. Okay. So, CMP basically specifies, okay, who, where, when, how all these particular things, you know, will perform the CM functions. Okay. So, in this particular aspect, you will be having a configuration management plan. So, the configuration management plan will typically tell you what? Okay. The configuration management plan will tell you how to perform the following activities. Okay. How to perform? First, how do you perform configuration identification? What constitutes a item? Okay. Now, take a simple example, again it is a little repetition, you know, but like suppose you had 6 volumes, you know, of a user manual. Do they constitute a single CI, or is it 6 CIs, you know, and the answer is depending on how you intend to use it. If you always plan to keep all the 6 together and issue and collect them and do whatever you do with them together, then it is a single item. If in case you want to use them individually or they get modified individually, you know, it becomes a separate particular CI. So, you will have to answer many questions, you know, like you have a simple thing like program specification, source code, you have a object code, you have test data input files, test data output files, and so on and so forth. You know, like how do you break them up, you know, into configuration items? So, somebody needs to have a clear guidelines as to how to identify an item, you know. So, first to decide what will and what will not be, you know, considered as a CI. Okay. Once you have said what will and will not, you say who will decide what is the CI, who will give it a name, number, and so on and so forth. Next particular thing is you will have to specify how configuration baselines are defined, identified, considered, you know, for recording and deployed. Okay. This includes, you know, that in case you need to have a backtracking, then this particular backtracking will also have to be done. Another important part is maintenance of configuration library, both the physical library and maintaining the metadata. Both these particular things will have to be done. Okay. So, who will do it? Who is responsible? Who will authorize? Who will issue? Who will take back? Who will make sure that what is being supplied back, you know, or issued out is what you say you are issuing out or supplied back. Okay. Access control and change control, you know, to the configuration. Who is authorized, who is not authorized to suggest, request, make changes. Then status accounting, again all these things, how to perform, who will perform, where it will perform, when it will be performed, that is all we are answering. Okay. Backup control, where do you, how, like every other particular software project backup, you know, you need to take backup of the configuration libraries also, you know. So, that again, whether you want to keep it at the same, like disaster recovery center, you want to keep it at the same place or at a remote site, and many other issues are involved in specifying how to take a backup control. Okay. The procedures, standards, tools used, you know, that also is very simple, which procedures will be used, which standard. For instance, suppose you have decided that you are going to take a starting baseline, in, you know, SRS baseline and development base, design baseline and integration baseline and end of the project baseline. And you may have a concern that for a large project these activities may take long, and in which particular case you might have a procedure or a practice which say that after initial baseline take the SRA baseline, but if the duration exceeds 3 months, then in any case take one baseline every 3 months and then take it at the appropriate end of phase. Similarly, standards will have to be specified, like how the items are identified, numbered and all kinds of things, where they are kept, then the tools which are used, lots of beautiful configuration management tools are available, and these tools can be used for checking items in, out, storing, versioning and all kinds of things. Last but not the least, the organization structures and the authorities that are there under the configuration management framework, okay, because configuration management activity also requires its own resources, its organization structures, authorities and so on and so forth. Okay. Last but not the least, we will have to do the referencing of all the particular documents, okay, and from that particular point of view you will have to say that this is how we actually do this particular job. Okay. So, if you were to look at this kind of a configuration management function, then we can now summarize it and say that the configuration management function basically consists of 5 major activities: configuration identification, configuration control, configuration accounting, status accounting, configuration audit and organizing for configuration management.